Hi, I am Atanu. In this tutorial video, you learn the factor theorem and the factorization of the polynomial. This is the series of the chapter polynomial class 9 mathematics. This is the part 4 video. Here you learn from the basic to advanced level, and in this video I covered the basic level, and for the advanced level you can join my online class also with affordable fees, and I advise you to complete this tutorial till end, so clear your concept and you can start the exercise yourself. So please share this video with your friends and like the video, and also press the bell icon so that you can get the notification. You can comments below, and as per your requirements or any doubt you can contact in my WhatsApp and Telegram channel also. So let's get started the video. So first we learn the factor theorem. So we know that the earlier video that the divisibility rule, and there we learned the remainder theorem. Actually the whatever shortcut we have learned for the find out the remainder of the polynomial, if the divisor is given, and without division by the shortcut method we can find out the remainder. You check the video from the playlist, you must watch that video, so it will be very easy to understand if you continue from that video. Clear? So what is the factor theorems? Factor theorems nothing but if we considered px as the polynomial, and if we know that if pa is 0, then we can say that if pa is 0, then we can say that px minus a is a factor, sorry, not px minus a, x minus a is a factor of px. Why? Because we know that with the general expression we know that px is equal to that is gx, that it is the divisor, and the quotient is qx plus that is the remainder. Okay, remainder is rx. So if it is divisible, completely divisible, means the factor means completely divisible. What is the definition of the factor? So we should remember this concept. What is the factor? If I told you what is the factor of 2x square, the factors are 2x and x square. Clear? These are the three factors, and also 1 and 2x square means number itself, and also the 1. Clear? These are the factor. So similarly, if I told you what is the factor of 12, so we know that we can prime factorize it. So this is 6 and this is 3. So what are the factor? Factor of 12 is equal to what? 1, 2, 3, 4, 6 and 12. These are the factors. So you should have clear idea about the factor. So this is the concept of the factor. Now here actually what happened when there is a factor like means this gx, gx is what? Gx is, just a minute, is the divisor, means it is given that x minus a and it is qx, but then rx becomes 0. We know that if pa is equal to 0, then r is equal to 0 if the x minus a is divisible by this px. Okay, so we elaborate this with some example so that you get this concept clear. So we can from this concept we can say that when the PA is equal to 0, the x minus is a factor of Px. So let's take one example. So actually you should know that if it is 0, x minus a, and that is qx, means from here the Px is equal to the x minus a into qx. So we can say that the x minus a is the factor of the Px from this assumption when the PA is equal to 0. So we can apply this concept on some example. Let's take suppose Px given that Px given that 7 x square minus 2 root x root 8x minus 6. So we have to find out that whether the gx is equal to x minus root 2 means x minus root 2 is a factor of px, means factor px or not. Factor or not, we have to check it. Clear? This is the question. How you can answer this question? Because we know that when is the answer, when we know that if one thing you should remember that when x minus 2 means if, not when, if x minus 2 is a factor, then root 2 will be the zeros. Zeros of px. This concept we have already discussed in the previous previous videos that is available in the playlist. You can check it. So if root 2 is the zeros of this polynomial px, then x minus root 2 will be the factor. Now we don't know whether this factor or not. Only we have to check that what is the, if it is whether it is zeros or not, we have to check it, right? So we replace the x with the root 2. So what value we get? We get 7 into root 2 square minus 2 root 8 into root 2, okay, minus 6, and you get what? You get 7 into 2 minus 2 into 16 minus 6. So this is 14, and this is 8, because 16 root is equal to 4. 4 to the 8 minus 6. So 14 minus 14 is equal to 0. So it is satisfied. Means root 2 is the zeros of the polynomials px. 0 is the polynomial of the px. So we can say that, since p root 2 is equal to 0, so root 2 is a 0 of px, or we can say that x minus root 2 is a factor of px. Factor of ps means factor of this given polynomials, factor of this polynomial. Okay, this is the factor of this, means x minus root 2 is the factor of the polynomial. It is satisfied. Okay, clear? With this method you can easily find out of the given gx. Here the gx is actually the divisor, that whether this divisor is a factor of the given polynomial or not, you can find out by putting this value. Putting this value into the variables. If when it will be 0, then you can say that 0 means what? 0 means it is completely divisible. This x minus root 2 is completely divisible. Means for your clear understanding, I just tell you one more thing. That is, if you divide this 7x square minus 2 root x minus 6 with this uh, x minus root 2, you get what? You get the quotient qx. This is also function of q and also polynomial, and you here you get the remainder. You get the remainder. After division, you get the remainder as a 0. Clear? This is the meaning of this factor. Clear? So this is the concept. Done. So now we learn the factorization of the polynomials. So let's take one example. There is a general example, that is, suppose ax square plus bx plus c is a polynomial, then it is a polynomial px. So it can be write as x minus a and x minus b. So this, since the degree of the polynomial is 2, the maximum factor could be the 2. Okay, it could be less, but maximum is the degree, equivalent to the degree. Here the degree is 2, so 2 factors would be maximum. So these are the factor. Clear? These are the factors. Okay. So first we learn. So next we learn the method of the factorization. Okay. First method is the factorization by taking out the common factor. So let's take one example. If it is, suppose, 2x square minus 3 minus 12. So what are those factors? You can write down the factor as, take the common. What is the common? 2. That is x square minus 12. X square minus 12. Clear? And but in this example, actually we can further factorize it, but it is not the cover in the method 1. Okay, so better we take the another example, that is ab a minus b plus c plus bc 2a minus b plus 2a minus 2b plus 2c plus ca 3a minus 2b plus 2c. Clear? This is the question. So you have to find out the common, right? Whatever common factors are there, we have to remove that. How you can do that? We can do by this. We write as ab 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 and a minus b plus c plus 2bc. Take common 2 here, it will be a minus b plus c, and here you can take common the 3. Sorry, here the question was different. That is 3. 3b 3c. So take the common 3 and again multiply ca 3ca, and what remain? A minus b plus c. So now we check it. These are the common. You can take the common again, that is a minus b plus c and a minus b plus c, and what remain is ab plus 2bc plus 3ca. Clear? So this is the answer. This way the example of the two example you get the answer. Okay, also let's take another example, that is 2x 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 plus 2x plus 3y a whole square minus 5 2x plus 3y. This is the third example. This is example 1, this is example 2, and this is example 3. How you can do that? So you take the common 2x plus 3y, and what remain? 2x plus 3y minus 5. Clear? Or no need to actually this bracket, you can with this step you can complete. So 2x plus 3y, here x square is there, so 1 2x plus 3y just remove, and what remain? 2x plus 3y minus 5 is the answer. Clear? Next we learn, this is the factorization by taking out the common factor. Okay, next we learn the factorization by the this is the method 2, factorization by the grouping terms. So let's take one example from the exercise, that is suppose the question given a cube x minus a square b and x minus y minus ab square yz minus b cube z. How you can do that? So how you can solve this? So first you remove, multiply and remove this bracket. A cube x minus a square bx plus a square by minus ab square y plus ab square z minus b cube z. Clear? So first of all, how we can choose this method? That is a question. So actually, when we cover the entire different method, then automatically you can understand that which method we choose shoot for that kind of question. So it is actually practice. By practicing, uh, you can easily find out that. Clear? So what is the meaning of the grouping? Grouping means, look at this. The x minus y minus z, there are the totally uh, different factors. So it is not particular these terms, actually the different factors. So particular these terms, so we cannot take the common any factor, right? Any common factor from these different terms, it is not possible. So we can change the group uh, so that we can find out a common factor, correct? So how you can do that? So this is the method of the grouping of the terms. Clear? So here actually we can take a square x, so what remain? Here it is remain a minus b square x plus here we can take what? A by. So what remain? Here it is a and it is by, means remain a minus b, and here it is what? We can take common b square, right? B square we can take common, and z also, right? B square z. So A minus B remain. Look at this. Look at this. We got the common factor, that is A minus B, from the each term. Clear? So this way, by the grouping, we can separate, means we can change the group and find out the common factor. Clear? So if we take the A minus B as common, and then the remain will be x square minus x plus aby plus b square z. This is the answer. Clear? Done. So this polynomial having the two factor, that is a minus b, and this part, this polynomial having the two factor a minus b, this enter this part. Clear? Next we learn the factorization of the perfect square polynomial. So let's take one example from the exercise, that is suppose this question given that, the example question given that, find out the factor of 25 3x minus 4y square minus 40 9x square minus 16y square plus 16 3x plus 4y here whole square. How you can do that? So here we have to easily find out that 25, it is a perfect square number, 16 also perfect square number. So we can apply this algebraic identity, that is a square minus 2ab plus b square, that is a minus b whole square. So by looking to the problem, you can easily identify this. So what will be next? So we can write as 5 3x minus 4y here whole square. Clear? Minus, here also we can take the common here, that is, and you can take the common, and you can jump one step also, or you can do like this. What you have to do, you just do this step, the next, that is 4 3x plus 4y here whole square. Clear? And inside you can write as 2 into 5 3x minus 4y and into 4 3x plus 4y. Now you check it whether this value match or not with this middle value. So 5 5 to the 5 to the 10 and into 4 is equal to 40. So it is okay. Clear? So now here it is a plus b and a minus b. So this thing we apply another algebraic identity, that is a square minus b square is equal to a plus b into a minus b. So it is hidden here, actually this thing hidden here. So we can do that. So we have done this one first, this one first, next this, and put the value inside here, so that it will we can check that this is match or not. We can, so otherwise what you have to do, you have to do the another step. Clear? You can do this step directly. Clear? Then what you have to do, so this is a minus b whole square. So 5 3x minus 4y minus 4 3x plus 4y is the whole square. Clear? Next what you have to do is you just multiply it, 15x minus 20y minus 12x minus 16y. Clear? And whole square. Okay, done. Next step is uh, 15 minus 12, so that is 3x, and here it is what, that is 6, uh, and 2 3, 36y, 36y, sorry, 36, 36, 36y a whole square. Clear? Further we can take common here, that is 3, and inside it will be, can, if you remove from the square it will be 3 square, and inside it will be x minus 12y square. So 9 into x minus 12 whole square. Clear? So these are the factor. Okay, clear? These are the factor. One is 9 and another two factor is x minus 12y, another is x minus 12y. Clear? This is the answer. This is the answer. X minus 12y. Clear? Next we learn the factorizing the difference of the two square. Here actually we apply the a square minus b square, that is a plus b into a minus b, this algebraic identity. So let's take one example, that is one example, a square minus b square minus 4c square plus 4d square minus 4 into ad minus bc. How you can solve this? So here actually we change the group with this method we apply. Actually the sometimes the factorization is actually combination method. So all the two or more method is applied in the same question. So here first we do the factorizing by the grouping the items. So group, we have to change the group because we can do anything, a square minus b square, and there is we can, if we take a plus b into a minus b, then also it will be this different if we take the 2c square minus 2d square, so there will be no common factor, so we cannot do anything. First we have to do the change the group by, first of all we just remove this bracket, a square minus b square minus 4c square plus 4d square minus 4ad plus 4 plus uh, plus 4bc. So one thing we can do, that is a square, and here it is ad, so we have to find out the a square and d square. So that we can apply this uh, algebraic identity, that is a square um, minus 2ab plus b square, so that we can get the a minus b whole square. Clear? So from this only we can identify what we have to do, minus 4ad and plus 4bc. So minus 4ad means a square should be there, a square, and we got it from here, a square, it is done, a square, and minus 2 into a into 2d, and then is equal to, we can write as 4d square. This 4d square we can write as 4d square, or we can directly write as 2d whole square. We get it from here. Clear? 2d whole square. So here we can apply the algebra identity, that is the a minus b whole square. Clear? And another grouping, what remain, we use this square and this one We have already used this one 4AD, and what remain? Remain is actually the 4C square. Here it is BC, right? So first we write the B square plus 4BC, and what remain? That is minus 4C square. Clear? Next step we can do that. So better this step you write as so that we can identify the group, that is 4D square. Okay, 4D square. So what we have done, we just we have grouped these three and separate from this group. Okay, this group, three group. This is A, 4D square and 4AD. Okay, clear? Just a minute. Change the cursor. Just a minute. Okay, so this is one group 4D square and this 4AD. Okay, and this is the another group. Okay, so next is A minus 2D whole square, or directly you can do, or but here we try the another extra step for your clear understanding. Okay, so A square minus 2 into A into 2D plus 2D whole square, minus, if we take the common here, B square plus 2 into B into 2C sorry, minus 2C square. Clear? So here is one group and here is another group, so it will be A minus 2D whole square, and here it will be B. So actually look at this, something wrong. B square BC actually will be the minus, okay, will the minus, because we take minus common here, it will be plus. Clear? So B minus 2C whole square. Done. The next step will be A square minus B square. You look at this, you think about that entire time is A is A square minus B square. Here you can write as A minus B into A plus B. So it will be what? A minus 2D plus B minus 2C into A minus 2D minus B plus 2C. So you get the result A plus B minus 2C minus 2D okay, and A minus B plus 2C minus 2D. Okay, minus 2D. Okay, done. This is the answer. It is not that much complex. Actually, you have to follow the step with the proper sign change. Actually, if you do the mistake with the sign, then it will be very difficult to get the answer. Clear? And next we learn the method 4, that is factorization by the splitting the middle term. This is applicable on quadratic polynomials. So there are also two types. The first we learn the first type. So type 1 is actually, if we get this like from x square plus bx plus c, okay, then what we'll do, let's take one example. that is x square minus 3x minus 28. How you can do that? Okay, here we just split. Suppose the roots are minus p and minus q, then we can write the factor as x p x plus p and x plus q, we can write as. Okay, so these are the factor. So how you can find out? So these are the product. Why? Because x square plus x p plus q plus pq. So pq is actually minus 28 and p plus q is equal to minus 3. So we have to find out the value of p and q. Okay, how you can do that? So first we write the product, that is 28, and this sum, actually this is the product. So then we have to factorize it, so that we get the product, the minus 28. What will be the two factor? So there could be the different combination, but we choose the different combination are, for example, 4 into 7, and you can put the minus here. But what will happen if we add minus 7? Minus 4 plus 7, what value we get? We get 3. So but here it is, sum is actually, this is the product, and sum is minus 3. So we are not getting the minus 3. But if we choose the 4 and minus 7, then what we'll get? So 4 minus 7, so this is minus 3. So it match the sum, it is matched. So we can write minus 28 as the 4 into minus 7, and minus 3 we can split as 4 minus 7. You can write as minus 4 7 minus 7 plus 4, you get the same result. Clear? Now we split the middle term, that is x square, and from here we get what? Minus 3 is equal to 4 minus 7, so 4x minus 7x plus 4x minus 7x. Then only we get the this sum is actually what? Minus 3. Okay, so next is minus 28, keep as it is. So next what I will do, take common x, so it will be x plus 4, and take common 7 minus 7, that is x plus 4. So now we check, we get the common factor, that is x plus 4. So we can write as x plus 4 and x minus 7. This is the right answer. Clear? Done. So what is the shortcut actually? What is shortcut is like that, since this is the shortcut. Shortcut is we know that it is x square plus bx plus c, we can write as x plus p and x plus q, and here we get p is equal to what? P is equal to 4 and q is equal to minus 7. Okay, so we can replace it, the x plus 4 and q is equal to x minus 7. Okay, plus of minus 7 means minus 7. So we get the same answer. Clear? Now we learn the type 2 of the factorization of the splitting the middle term of the quadratic polynomials. For example, if the general expression of the polynomial is ax square plus bx plus c. Can you compare it with the earlier example? Here actually missing a is missing, means a is actually 1, but here actually a, the variable, is there. So if it is like this form, then what we have to do? So here we consider the product as AC, okay, and sum remain the same, that is the B. So this way we just we include the sign also to get the product, and this way we find out we split the middle term. Clear? Let's take one example. So let's take one example. Just a minute. X root 2 x square minus 10x minus 4 root 2. Okay, how you can do that? Uh, is you have to find out the product. Product is equal to what? 7 root 2 include sign minus 4 root 2, then minus 28 into 2. So this is minus 56. Clear? So product is minus 56, and sum is what? Sum is equal to minus 10. So now we have to split both sum and the this product also. How you can do that? If we choose since it is minus, so always you choose the higher value of the number minus sign. So 14 into 4, 14 into 4. Clear? And here we can also get the same result. If we split like the minus 14 plus 4, we get the minus 10. So my assumption is correct. This split is correct. So we can apply this here. 7 root 2 x square minus 14x plus 4x minus 4 root 2. If we take common 7 root 2x, what value we get? Remain, that is x, minus here 14 we can simplify as 14 into 7 into root 2 into root 2. Okay, if we take the 7 into 2, that means 7 into 2 is equal to 14. So if we take this 7 root 2 common from here, what remain? That is root 2 x, and here if we take the common, x minus root 2. It is not the x actually, 2x. Clear? So now these both factors are same. These are same. Okay. So x minus root 2, take the common factor, and what remains? 7 root 2 x plus 4. This is the answer. Clear? Here the shortcut method is little complicated, so better you do follow this method to get the answer. Clear? Now we learn the factorization of the polynomial by applying the algebraic identities. So let's just list out the all algebraic identities. So first one, if we get the polynomial like this form, a square plus 2ab plus b square then we can write this as a plus b whole square. Okay, or a square minus 2ab plus b square. If we get this polynomial in this form, we can easily write as a minus b whole square. If we get the polynomial as a square minus b square, we can write it as a square minus b square a plus b into a minus b. Okay. Then if we get a square minus what is next, cube, that is cube. Just a minute. If we get the polynomial in this form like a cube minus first is consider the plus plus 3a square b plus 3ab square plus b cube, then we can write as a plus bl whole cube. If we get the polynomial as a cube minus 3a square b plus 3ab square minus b cube, we can write as a minus b whole cube. And if we get the polynomial as the a cube minus b cube minus 3ab to a minus b form, then also again we can write as a minus b whole cube. Okay, actually these are the same. Done. These are the same. Next is a cube minus b cube. Okay, a cube plus b cube. If we get the polynomial as a cube plus b cube form, we can write as a plus b to a square minus ab plus b square. If we get polynomial as a cube minus b cube form, then we can write as a minus b a square plus ab plus b square. Clear? Next is just a minute. If we get the polynomial as a square plus b square plus c square plus 2ab plus 2bc plus 2ca form, then we can write as a plus b plus c whole square. Here a plus b plus c is plus sign whole square. Next is a cube plus b cube plus c cube minus 3abc minus 3abc 3abc, we can write as a plus b plus c a square plus b square plus c square minus ab minus bc minus ca. Clear? And another condition, a cube plus b cube plus c cube will be 3abc when, look at this, if if it is abc is 0, just a minute, if abc is 0, then this enter value will be what? Enter value will be 0. Clear? So we get when we get this value, when a plus b plus c equal to 0. Clear? So most of algebraic identity cover here. Okay, let's check it. Let's take one example from the exercise. Suppose question given that, so first of all you have to remember all this above algebraic expression identities. This algebraic identities you have to remember to identify the polynomials before applying the identities. Okay, so for example, question given that one question given, just a minute, x cube minus 1 by x cube uh, minus 1 by x cube minus 2x plus 2 by x. Now uh, we can't apply here, we cannot apply this formula. If we take common minus 2, we get x minus 1 by x, but if we want to apply this formula, it will be not possible. That is a cube minus b cube, where it is, a cube minus b cube, a cube minus b cube minus 3ab into a minus b is equal to a minus b whole cube. We cannot apply this formula because here is not available any 3, correct? We cannot apply this formula, so we have to apply the different formula, different identities. That is first we apply the a cube minus b cube, where it is, a cube minus b cube, here a minus b into a square plus a plus b square. Clear? So what will the answer? A minus b, first we write down the question, so minus 2x plus 2 by x is equal to x minus, this was the question, okay. So a cube minus b cube is a minus b a square plus ab plus b square, okay. And here it will remain 2x plus 2 by x, or simply you can take common here 2, then what remain, x plus 1 by x, plus 1 minus x. So now x minus 1 by x, and here x minus 1 by x is, we can take common, so x minus 1 by x, and what remain, x square plus, and this is cancel out actually, x and 1 by x cancel out, so it will be what, 1 plus 1 by x square, and here it remain 2 minus 2. Okay, done. Next, x minus 1 by x and x square plus 1 by x square minus 1. This is the answer. Clear? So you have to remember the all algebraic identities and follow this step. You have to identify that which identity will be suitable for this polynomial to factorize it. Okay, clear? Now take another example, that is p plus q, just a minute, p plus q whole cube minus q plus r whole cube plus r plus p whole cube plus 3p plus q plus r and r plus p. Here, this is the question. So how you can do that? So we have to take one example. Let's take one example, that is one example is L plus 3m cube minus 3m minus 4n cube minus 4n plus L cube. Okay, so we have to factorize this polynomials. How you can do that? So if we consider a as, let a is equal to L plus 3m and b is equal to minus 3m plus 4n, okay, and c is equal to minus 4n minus L, okay. So we can arrange the given this polynomial as L plus 3m whole cube minus 3m minus 4n whole cube minus 4n plus 1 whole cube as whole cube plus minus 3m plus 4n whole cube plus minus 4n minus L whole cube as a cube plus b cube plus c cube. Okay, we can write as assume. Okay, so now we can find out the a plus b plus c. That will be a plus 3m minus 3m plus 4n minus 4n minus L. Now we check it. This is L cancel out, and here 3m cancel out, and 4n cancel out. We get the 0. Now we can apply this. Okay, we can apply this algebraic identity with this condition. When a cube plus b cube plus c cube is equal to 3ab, it will be 3abc when a plus b plus c is equal to 0. So the factorize of the px is equal to so abc is equal to, so you can write as so a cube plus b cube plus c cube is equal to, we can write as abc. Okay, abc 3abc 3abc. So it will be what? 3 is now replaced with the abc. A is equal to what? L plus 3m, b is equal to minus 3m plus 4n, and c is equal to minus 4n minus L. Clear? Now if we take the common L plus 3m, and here we take the common minus, and here the minus, then both minus cancel out, and you get 3m minus 4n and 4n plus L. This is the right answer. Clear? So that's it. Actually, this is the end of the factorization and of the polynomials. Thank you for watching this video till end. You watch this video till end means you have that much potential and patience to spend time to learn the new things, and you can start practicing your exercise And also when you watch this such video, you must take the notes in your notebook, and you can apply your knowledge to do your exercise. If this video is helpful to you, please share this video with your friends and subscribe my channel so that it can grow, and I'll be motivated, and just in future I will upload the more such videos. Okay, thank you very much. See you in the next video. Bye.